We can see here, if I press button number 1, blue dye, and at this point we actually have red dye in the unit, it will start appearing right here and here. The dye in the alluvial aquifer will slowly move across into the Mississippi River. If you look close, you can see it already moving in, thus showing that any water within this area moves towards the river. Now we can also pump one of the wells by pressing a button and see how that groundwater flow has changed. These wells start pumping. The dye begins to move downward towards the well. This is unaffected because it's on this side of the river. This is a bit of a divide here. Water comes up, but this is a divide line. These wells don't affect this over here too much. If we pump these wells continuously, in other words, someone keeps hitting the button, and it runs for 55 seconds at a time, and keep hitting it, eventually the Mississippi River from overpumping will start to drop. Nothing more is happening. You can see the dye moving again. Again, we waited our delay. You notice the time before I pressed it, nothing happened. This time, more dye is moving in. We can move across the model to the embayment aquifer system. We also see our wells number 3, 4, 5, and 6. By pressing the dye here, it's going to appear right here and right over here. And the user will hear the pump running in most cases. This dye is going to move slowly down the aquifer. You can see it already starting to move. It will move across towards the Mississippi discharge. This one will move a little bit deeper and will come across also and discharge to the Mississippi River. Later on we'll talk about some hidden valves that are down here, and we can cause the dye to move deeper into the aquifer for a more advanced demonstration where you have an instructor up here talking to a group of people or a classroom. But you can see it slowly moving. You can pump the wells at this point and see the effect. For example, watch this plume right here. It's now right over here. I'm going to pump number 6. Instantly we see dye moving back. Now because of the confining layer, this is not really affected that much. But this dye is being pulled into well number 6. We can start well number 5. Because there's breaks in the layer, we may see some of that dye moving across, right here. It's going to move down towards well number 5. Small breaks right here. Now number 6 has stopped working. No longer any dye going up, so this plume is now moving across again towards those breaks, down the aquifer. Notice that dye moving down here towards number 5. We've also got dye continuing in this direction towards number 4 and number 3, so something like this. Look at the blue dye again. Again, nothing's happening because of the lockout period. Continue to move across. This well has stopped pumping, so now the dye is again moving across, showing the changing groundwater flow, but now it returns to normal. And and it will look for another break in the confining layer to move up to this area. The movement is going to be fairly slow. When we're talking real-world conditions, we could be talking hundreds of years for this groundwater to migrate through some of these layers in the Wilcox and Midway, and even the Claiborne. For those to move over to the Mississippi River can take hundreds of years. In our model, it will probably take about 3 to 5 minutes for that dye to completely move all the way over to this point, assuming that they aren't pumping any wells. If we start pumping number 4, you can see the red dye getting close. There's a very nice trace there going up. Coming down, you can capture by number 4. This is one of the ways they'll clean up an aquifer, by trying to capture all of the contamination flow. Just put more dye in. The delay period has been off. It's been long enough now to put some more dye in. And again, that will slowly move this direction. I'm going to step over to this aquifer here, and we'll start looking at that while we're waiting for that dye to move across. As I said, in the southeastern coastal plain aquifer system, we have the Black Warrior River aquifer, and that runs down to this area. One thing I should note is I talked about groundwater movement staying up in this area. And you can see that starting to happen. It's starting to move across right through there. This one's going to go down and move across. This area right down here has very little groundwater movement at all. These are very deep. We're probably talking 2,000 to 2,500 feet deep. And so that area will tend to get, because it's slow movement, it will tend to get very high dissolved solids, saline waters, a lot of salts, a lot of dissolved minerals. It's not any good for drinking water. And so you notice all our wells stop all right around the sea level to 500 foot level. This water down here isn't any good. In an advanced use, an advanced demonstration, you can adjust valves in the back, and we'll show that a little later in the video. It will cause some red dye to go down in these areas and essentially stagnate to represent those areas that are poor quality water. We wanted to do that. But here in the Black Warrior River aquifer, we've got one well, we've got a septic system, and then 2 dye injection points. So we can press the septic system button. And this would represent the effects of thousands of septic systems, which are common up in this rural area of the state. And what you'll notice right away, it moves right into the Tom Bigby River. Flowing right in, changing the water quality there in the river. Some of it will move a little further down, but most of it's going to come right out into the river. The second injection point is going to be right here, and also right here. And we did that to show 2 things. First of all, again, that slow movement. You can see that groundwater divide. We've got water coming in this way, water coming in this way. This dye will not move over to this side. It's going to come right in here. This is going to come in right in here. This dye plume, we put it right at the point at which the groundwater separates from the shallow flow, which is up towards the river, and the deeper flow, which is down this direction. And so what you see is this plume's dividing. Some of it's going here, some of it's going deeper into the aquifer. This is going to move very, very slowly down towards this area. It'll probably start to stagnate around this area unless we open some of those valves in back, which then you can move it deeper into the aquifer. But we want it to go towards number 7. So again, notice your traces. And we'll look back over here, because that dye's moving along. There's a nice trace showing how that's moving towards the river. We can pump number 3 while we're waiting on this. Look at the distance between it there. If I reach over, turn on number 3, watch the dye trace. You can clearly see now the changing groundwater flow paths compared to what it was. Hold it up within the aquifer. And so you can see that movement across that area. If we were to pump number 6, it's probably too far away to pull it back. It might pull back some of this. But this down here is not going to pull back. It's already past this point. This is going to move back towards 6. Again, look at that nice trace. Showing how that's affecting the groundwater flow on the base of a well. Number 6 is a small trace, but this is not going anywhere. When we hit number 5, we should again see a really nice trace there. There's the trace. This up here is going this way. This here is going down this way. Number 3 is going up. 4. And then the overall flow is this way. Back over here, you'll notice most of our septic has discharged into the river. Cleaned up. Most of this is discharged in. It's gone. This is still a dividing line of the groundwater flow. So if I hit number 7, I should slowly be able to draw that in towards that well. The movement's going pretty slow, but it'll start to pull down in towards that well. Back number 5, you can see a nice trace there. And the overall flow to that river. Notice this down here is not getting any of that dye. Fairly stagnant water down there, very little flow. And it's interesting because in the real world, what happens to this aquifer is right when it gets to here, the groundwater flow starts to go this direction, towards Florida. Over in this area, it comes down and then starts to flow more towards the Gulf, discharge down by the delta. We're talking discharge that's so minimal that it's almost considered stagnant in some areas of the aquifer. The water just doesn't move and hasn't moved for a long time, thousands of years, or if not more. For this, we can hit number 7 on again. Keep drawing that down in. And this dye has waited long enough that we press it again, it'll appear again. And same with this over here and here. Here and here and here. So we put a delay in so there isn't a constant hitting of the buttons and using up all the dye really quickly and polluting the model. But the delay isn't a long period. Usually if there's little interaction, if they're reading this material up here, they're interacting with the model, then they can keep pressing the dye, keep pressing the pumps. We have no delay into the pump. You can hit pumps, and they'll all just start pumping. And you see the effects on it. So that's the basic operations. You can see here number 7, we're getting a nice trace there. Kick that on again.